A local Laguna S 2.1 deployment built this polished browser game from one fixed brief. The first, faster no-thinking run looked good, then crashed near the first shockwave and scored 60 out of 100. A much longer thinking-enabled run removed that crash and initially appeared to score 94. Then a human actually played it. Normal steering felt too sluggish, and the dash was not really a dash. After objective-level playability testing, we revised the second score to 82. This video is about why visual quality, runtime stability, and playability need separate tests. The artifact was Unsloth's Laguna S 2.1 GGUF, a 118 billion parameter mixture of experts model with about 8 billion parameters active per token. The Quant was UDQ4KS, served through llama.cpp fingerprint B10109-0CEA36222. This is not BF16 and not Poolside's official agent harness. It is a deployment case study, model, quant, runtime, chat template, context, slots, thinking mode, and our confined file tools. One brief, one run per condition, and no human game code edits. The first deployment used 262,912 context tokens per slot, 4 slots, and thinking disabled. It used 19,266 completion tokens and took about 4.6 minutes of client time. Independent browser QA confirmed the tutorial, movement, dash display, and sentinel damage. But the first shockwave passed a negative radius to canvas. The animation loop stopped with the HUD frozen near 86 seconds. That original score remained 60 out of 100. We did not overwrite it. For the follow-up, we reloaded 524,288 context tokens into one slot and enabled preserved thinking. The GPU power limits were user-reported as 300 watts for the RTX 3090 cards and 350 watts for the RTX 4090 cards. Short decode tests ran near 55 tokens per second. A 1 million context attempt was excluded because it became abnormally slow, exhausted huge reasoning budgets, and returned no usable final response. Context, slots thinking, active context, and power limits all changed, so this is not a causal test of thinking alone. The 524K thinking trajectory used 13 turns and 132,330 completion tokens. Client time was about 52 minutes, while generation speed declined from roughly 52 to 36 tokens per second as active context grew. One streamed file write hit the 16K response cap in the middle of its tool call JSON, which caused an HTTP 500 on the next request. We repaired the harness, preserved completed reasoning and valid tools, and resumed without editing the game source. The trajectory later hit its total completion cap. It produced the game and a plan, but no readme, self-QA report, or normal final response. The unmodified follow-up artifact did fix the initial runtime failure. Independent browser tests exercised tutorial, focus, movement input, all 3 hazards, shard collection, win, timer loss, integrity loss, and restart. A real 91.6-second timer run reached time expired with multiple shockwaves and 0 JavaScript page exceptions. Visually, the neon cyan, violet, amber, and coral design is coherent. The tutorial, HUD, effects, windscreen, and lose screen look like a finished arcade prototype. That improvement is real, but it is not. Our first follow-up QA asked whether movement changed position and whether dash activated. Those checks passed, so we initially scored the artifact 94. But that was too mechanical. In actual human play, ordinary steering felt slow and unresponsive against dense hazards. The player accelerates at 500 pixels per second squared toward a normal maximum of 300. Reaching maximum speed from rest takes about 0.6 seconds, and fully reversing direction takes about 1.2 seconds. With only 3 integrity points, 4 sentinels, 3 gravity wells, and shockwaves every 3.6 seconds, that inertia matters. The source revealed a concrete bug. During dash, velocity is set to 900. Later in the same update, an unconditional speed limiter clamps every velocity above 300 back to 300. Our instrumented reproduction shows the dash effect and cooldown, but actual speed stays at 300. A keyboard-only autopilot won in 16.2 seconds when made invulnerable, proving the map distance is not mathematically impossible. Under normal damage rules, 3 normal trials and 3 dash-enabled trials all lost after collecting 5 or 6 shards. The bot did not use sophisticated avoidance, so that is not proof that no skilled player can win. It does show that dash added no real speed advantage. We revised the thinking artifact from 94 to 82 out of 100, 35 for functional completeness, 21 for reliability and UX, 19 for visual quality, and 7 for agentic execution. The no thinking artifact remains 60. The second deployment fixed the crash and produced a much broader, more stable game, but poor movement tuning and the 900 to 300 dash clamp prevent a fully successful result. The larger lesson is simple. An artifact can look finished, pass source checks, expose every requested state, and still fail the moment playability becomes a first-class test.